For this video, we're going to be discussing Venn diagrams. So I'm sure you've seen a Venn diagram before. Venn diagram is made up of circles, usually 2 or 3 circles. And they're used to show the relationships between two sets of data. Okay, so here I've got a Venn diagram with 2 circles. Here I've got a Venn diagram with 3. All right, and what they're showing is they're showing the relationship between these sets. So over here in A, or in this one, I've got things that belong to just A. Here I've got things that belong to just B. And here I have things that belong to both. So for example, I said these are even numbers and these are prime numbers. Well, over here in prime, I'm going to have 3, 5, 7, 11, so on. Over here in even, I'm going to have like 4, 6, 8, so on. And here in the middle, there's only one number that is both even and prime. That's 2, so that goes in the middle there. All right, and this is a similar Venn diagram for for 3 circles. And one thing that a lot of people forget about Venn diagrams is there's always a third region, or there's always an other region. Venn diagram really should have a box around it. And here I've got even numbers. Here I've got prime numbers. And what I need to have out here is things that belong to neither even nor prime, like 1. 1 isn't even, and 1 also isn't prime. So 1 goes outside. Right? There's always got to be an outside region, and that outside region is for things that belong to neither one of these. All right? Something else to talk about, some vocabulary words. The intersection of two sets is that spot in the middle where they cross, things that are in both. And it's represented by this upside down U. So A, the upside down U, and B, that means A intersects B, and it's where the two cross. It's the things they share. The union of these two sets, which is shown by a U, A, U, B, is all of the things put together. All right, so if, for example, I just put in here like, oh, that got all messed up. Well, here, let me show you an example. If I draw 2 circles, let's call this B and A. And, well, for example, if I go back to my prime and even, right, I had in here, these were evens, so 4, 6, 8, so on. Here's 2, and here was 3, 5, 7, so on. Well, if I put those, well, actually, let's make it easy. Let's just make it, and let's try a different thing here. Instead of putting those dots, let's just make it 4, 6, 8, 2, 3, 5, 7. This will make our lives a lot easier. And we'll call this B again. And we'll call this A. If I wanted to find A intersect B, well, there's only one thing in there. That's simply 2. A intersect B is the part where they cross, and there's only one thing in there. It's 2. If I want to find A union B, well, that's all of this stuff, so there's a whole lot more. That's 2, 3, 4, 5, 6, 7, 8. The union is everything. All right, so intersection is the things where they overlap, the things they share. The union is everything. So we can use Venn diagrams to answer some questions. So here's example 1. Example 1 says, use the Venn diagram to answer the following questions. So I've got this Venn diagram, and my Venn diagram is about professional tennis players playing in these 3 tournaments, the US Open, Wimbledon, and the Australian Open. So let's answer some questions. Question 1 says, how many professional tennis players competed in the 3 tournaments? Well, this is a pretty easy question. I'm just trying to figure out how many competed in these 3 tournaments. So I go in my 3 tournaments, and all I have to do is add up every single number in here. Now, I don't have to worry about this 30. The 30 corresponds to people who didn't play in any of the tournaments. So let's figure out how many people played in the 3 tournaments. We got 50, 80, 100, 110, 150, 165, 170. 170 tennis players competed in the 3 tournaments. Right? All I did was add them all up. Number 2 says how many competitors were there at Wimbledon? Well, here's my Wimbledon circle, and I'll kind of outline it in blue. So that's my Wimbledon circle. So my Wimbledon circle, I just want to count up everybody who played at Wimbledon. Now, some people played at Wimbledon and the US Open. Some played at Wimbledon and the Australian Open. Some people played at all 3. Some people just played at Wimbledon. But the question is asking me how many competitors were there. And to do that, I just add up these 4 numbers. So 30, 40, 80, 95. So there were 95 competitors at Wimbledon. All right. Now, question number 3 says, how many players competed at just the US Open? Only the US Open. Well, in this circle here, this is my US Open circle, but I want players who competed at just the US Open. So not Wimbledon, okay, not all 3, and not the Australian Open, just the US Open, so there are 50 of them. And finally, number 4 says, how many professional players were there for the year shown? Well, I've already added up all the players who played at these 3 competitions. That was 170. And now I've got to add in my 30 who didn't compete at any of these competitions. So 30 plus 170, 200 players. So you can see how exactly we use a Venn diagram like this to answer some questions. Now the other way is we can use given information to create a Venn diagram. So it says this year there are 350 8th graders. 40 are taking geometry, 137 are taking Spanish, and 17 are taking both. Okay, so I'm talking about geometry and Spanish. So let's make geometry and Spanish my 2 circles. Well, if I can make it draw a circle for me. Okay, so let's make geometry and Spanish are my 2 circles. Okay, and well, you'll just have to trust that they overlap because they don't want to draw it in here. I'll draw in their overlap for us here. Good enough. Okay, so let's call this one geometry. We'll call this one Spanish. And I'm going to put a box around these, and I'll show you why in a minute. All right. And I'm going to call my box the 8th grade. All right, so what information do I know about the 8th grade? I know there are 350 8th graders. Okay, so in all the 8th grade, there are 350. I know 40 of them are in geometry. Okay, actually, I don't want to write that in there. 40 of them are in geometry. And I know that 137 are taking Spanish, and I know 17 are taking both. So there's 17 here. Okay, that's easy. 130, so let's figure out, well, if there are 40 taking geometry and 17 are taking both, how many are taking just geometry? Well, that's easy. I just do 40 minus 17. That's 23. So 23 students are taking just geometry. Now I can do the same thing for Spanish. I do 137 minus 17. That gives me 120. So there are 120 students taking just Spanish. Now, am I done here? Well, no, I'm not. I've got 350 8th graders. All combined here, I have 177. So where do I do with my other students? Well, 350 minus 177. What do I get there? 3, 7, 173. All right. I've got 173 students who are not in either one of these circles. So what do I do with them? I just put that 173 out here because those 173 students are not in geometry or Spanish or both. And now my Venn diagram is complete. So hopefully you can see how we use the given information to fill in our Venn diagram. All right, so that's about it. So tonight's try-it problem is simply to answer these questions about students' favorite sports. Given the picture here, I want to know how many students like basketball and soccer, but not baseball, how many students were polled, and how many students like baseball. So that is your try-it problem for tonight.